Fractional indices have the format of, let's say, a raised to the power of x over y. Okay, that means the index here is fractional in the sense. So we understand that square root is the reverse of the square of the expression. So we can say that the square root of x, okay, multiplied by the square root of x will be equals to x. Now, how do we prove this? The square root of x is the same thing as writing x raised to power half. Therefore, if you change the term of square root of x, we will have x raised to power half multiplied by x raised to power half. And if you apply the law of addition, or the addition law here, we have x raised to power half plus half, which is equals to x. Okay, and in the same vein, when we have x raised to power 1 over 3, we have it to be the cube root of x. What this means is that a number that will be multiplied 3 times to give x. So we can say that the cube root of 27, okay, is 3, because 3 times 3 times 3, okay, is equal to 27. So we can have a table. We can say x in power, or in terms of the power, and the symbol of the root. Okay, so we can say that x raised to power half, that's the square root of x, will be written like this, and x raised to power 1 over 3, that is the cube root of x, will be written like this. X raised to power 1 over 4, that means the fourth root of x. That means the number that will be multiplied 4 times to give x. And x raised to power 1 over 5, that is the fifth root of x. The number to be multiplied 5 times to give x. And it continues like that up to x raised to power 1 over n, that is the nth root of x. The number that will be multiplied n times to give x. So having an understanding of this now, how then do we come about fractional indices? Okay, how do we come about fractional indices? So we know that x raised to power 1 over n, okay, is equal to the nth root of x. Therefore, we can say that x raised to power, let's say p, let's use another variable, yes, p over n. Now, x raised to power p over n here, we can rewrite it in terms of product law. We recall our product law formula that says x raised to power a multiplied by b is equals to x raised to power ab. Okay, or I think we used a raised to power x is equals to a raised to power xy. Now, we can rewrite this to give us x raised to the power of p, all raised to power 1 over n, or we rewrite it as x raised to the power of 1 over n, or raised to the power of p. Either ways, when we multiply p and 1 over n together, p and 1 over n together, we will have p over n. So in the same vein, when we write x raised to power p over n, we will have x raised to power p raised to power 1 over n. And we know that x raised to power 1 over n in the format is the nth root of x. Therefore, we are considering this as is the bracket. Therefore, x raised to power p over n, which is the same thing as x raised to power p raised to power 1 over n, will be the nth root of x raised to power p. So we can write it in this format as 1. Remember that we can write it in 2 ways. We can write it like this, 1, and like this, 2. So therefore, if you write it as x raised to power p over n is equals to x raised to power 1 over n, all raised to power p, we then consider it that it is nth root of x, all raised to the power of p. all the same, this means the same thing. So the denominator, so we can come to a general conclusion of a raised to the power of x over y is equal to the white root of a raised to the power x, which is also the same thing as the white root of a all raised to the power of x. Okay, so we consider the denominator as the root and the numerator as the power. So we can write it, the denominator is the root and the numerator as the power or index by which the value will be based. So in our next video, we will take a look at how to apply this principle and when we come to dealing it in numbers.